Welcome back to the deep dive. Today we're tackling something truly fundamental, maybe the most important technology ever. Fire.
Absolutely. But we're going beyond just, warmth or cooking.
Right. We want to trace the technical side. How did we learn to use it for making things? What problems did it solve?
And how did that shift things for early human societies? It's really about the dawn of material science.
Okay, so where does the story begin? We're talking way back.
Yeah, like 1.5 million years ago, maybe. But initially, it's just using what nature provided.
Like lightning strikes or volcanoes?
Just happening upon it.
Exactly. Passive use. We see hints like burnt bones in caves in South Africa, maybe 100, 150,000 years old, but that's still relatively late in the using natural fire game.
So the first big technical leap wasn't making fire, but controlling it, managing it.
Precisely. Moving into the Middle Paleolithic, say 300,000 years ago, we see the first proper hearths, like deliberate structures.
Not just a campfire pit. No, more sophisticated, sometimes ringed with stones. You find examples in China designed for better combustion, more control.
Okay, that makes sense. But actually starting a fire whenever you need one,
Yeah.
that feels like the real hurdle. How did they cross that?
That's the true technical revolution, I think. Artificial ignition. It seems to pop up maybe 200,000 years ago,
Yeah.
possibly even earlier, but solid evidence gets clearer later.
And how are they doing it?
Well, two main ways emerge. We've got the strike-a-light method. Neanderthals were definitely doing this around 50,000 years ago.
It's hitting rocks together.
Sort of. Hitting flint against something like iron pyrite.
Yeah.
It makes a spark.
Hmm.
And we know, because we find their hand axes in places like France with these very specific wear marks from striking.
Wow. Okay, and the second method?
That's friction. Probably developed a bit later, in the late Paleolithic. It seems linked to advances in drilling technology, actually.
Ah, so rubbing sticks together, that whole thing.
Basically, yeah. Generating heat through friction until you get an ember.
Yeah.
That gives you real, reliable fire on demand.
And why was this control so critical? What problem did it solve in tool making?
The big one was hardness. Stone is hard to work. Napping, shaping it takes incredible skill. It's unpredictable. Lots of mistakes.
Right, I read it could take months, maybe 6 months, just to get competent.
Exactly.
Yeah.
Fire offered this, well, kind of counterintuitive solution. Heat the stone first.
Heat it. Wouldn't that make it harder?
You'd think so. But no, for materials like silcrete, and we see this at pinnacle point around 72,000 years ago, heating actually makes it more brittle.
Brittle. So easier to break.
Easier to control how it breaks. It relieves internal stresses, makes the fracture predictable. The results were pretty dramatic.
How dramatic.
Experiments show you could get flakes that were maybe 20–30% longer. The cutting edges were sharper angles reduced by like 30 degrees. And crucially, fewer mistakes. Error rates dropped by over 60%.
That's huge. It makes the whole process more efficient, easier to teach too, right? You can see the change in the stone.
Absolutely. It lowers that steep learning curve. And think about the thinking involved. Nailing down the right temperature, maybe 350, 400 Celsius for flint, that's systematic experimentation.
The beginnings of scientific thought applied to materials.
Definitely. And this mastery over heat opened up totally new possibilities. Not just shaping stone, but new technologies altogether.
Like what?
Well, indirect heat. Think stone boiling. At Shudanggu in China, around 110,000 years ago, they found thousands of fire-cracked rocks.
Not for cooking on, but for heating with.
Exactly. Heat the rocks, drop them into water or some other liquid in a container, maybe a hide bag or a vessel, to cook soups or stews. That's a whole new way of processing food.
That requires planning. And then there are composite tools, right? Sticking blades onto handles.
Yes. Fire was key there, too. You need adhesives like birch bark tar or plant resins. You get those by carefully heating the raw materials. That lets you attach a sharp stone point to a spear shaft or an axe head to a handle.
Creating specialized tools, specialized weapons, game changer.
It really is. And this whole journey learning to find fire, then manage it, then create it, then precisely control its temperature for different tasks.
Like heating bone to make it harder, maybe 600, 800 degrees?
Exactly. Or heating flint just enough to make it workable. That laid all the groundwork, the fundamental understanding of heat treatment, that was necessary for the Metal Ages.
Bronze, iron, they all depend on even higher controlled temperatures.
Right. You don't get to smelting ore at 1,000 degrees or more without first mastering these earlier steps. Modern steel needs over 1,500 degrees C. It all builds on that Paleolithic foundation.
So fire wasn't just about comfort. It was applied material science. It changed our whole relationship with the physical world.
It truly did. It's the ability to predictably transform matter using energy. That abstract leap time plus temperature equals a desired outcome. You can draw a straight line from that first controlled hearth to, I don't know, semiconductor fabrication today.
Every industrial process owes something to that first spark. Amazing.
It's the bedrock of technology, really.